Mankind has always been interested in what the Earth looks like and in its place in the universe. Today, everyone knows that the Earth is a sphere and that it rotates on its axis once every 24 hours. Because of the work done by Copernicus, Galileo and Newton, this was generally known to people in the 19th century too. But there was no visual proof, not until one was provided by a man who had been expelled from school and had never obtained a university degree. Jean-Bernard Léon Foucault was born in Paris on the 18th of September 1819, the son of a publisher. At an early age, he showed that he was good with his hands. He built model boats, telegraphs and steam engines. In 1829, he was enrolled in a well-known private school, the Collège Stanislas. He was anything but a model pupil, and eventually he was expelled. After that, he was taught by a private tutor. He then proceeded to the University of Paris to study medicine, but he was so nauseated by having to dissect cadavers that he soon dropped out. Foucault got a post as assistant to a tissue analyst, Alfred Donnet, who performed microscopic examinations of milk and bodily fluids such as blood. In 1840, the pair of them presented a process by which detailed images of the samples could be made. They used the newly invented daguerreotype technique, an early form of photography. Their source of illumination to start with was sunlight, but Foucault was always on the lookout for technical improvements and experimented with the arc lamp as an artificial light source. He was the first rods made of gas carbon rather than charcoal. In this way, incidentally so to speak, he was the inventor of the carbon arc lamp as a practical form of lighting. In 1844, Donnet and Foucault published a medicinal atlas with 80 prints taken from micro-daguerreotypes. The scholarly periodical Journal des Débats also commissioned Alfred Donnet to report on the sessions of the Academy of Sciences, a task he was soon delegating to his assistant. This was to be the decisive turning point in Foucault's life. He now finally had access to the Holy of Holies, where French science was concerned. Together with his former schoolmate, Armand Hippolyte Fizeau, he succeeded in producing the first daguerreotype of the sun. The image clearly showed that the sun's disk is brighter in the middle than at the edge. Foucault and Fizeau also collaborated in other fields, investigating the infrared spectrum and the refraction of light. They also hoped to come up with an answer to the vexed question of the nature of light. There were two camps, those who believed light consisted of waves and those who thought it was particles. Foucault and Fizeau designed an experiment to decide the issue. When a beam of light passes from air into water, it is refracted. According to the particle theory, light would have to travel faster in water. Wave theory predicts that it goes more slowly. The practical problem is the very high speed of light. Foucault and Fizeau first had to develop a new technique for measuring it. This required apparatus whose parts moved as evenly as possible. The two researchers pursued different lines of approach. Fizeau used a toothed wheel driven by a steam engine. But Foucault won the race. His rotating mirror system was far more accurate. In April 1850, he proved that light slows down in water, so the wave theory seemed to be correct. Foucault calculated the speed of light to be 298,000 kilometers per second, less than 1% off of today's best value. But he was still some way away from the climax of his career. In 1851, he demonstrated what was probably his most important experiment, the one with which his name was to become synonymous. The invitation said, "You are invited to watch how the Earth rotates." Scientists had been seeking to prove this for 200 years. They had been dropping weights from towers or into deep wells. Some had even tried to fire cannonballs vertically upwards to detect the slightest deviation from their paths. But every attempt to prove the rotation of the Earth in this way had failed. Jean Foucault was not an academic scientist, but a brilliant experimentalist, craftsman and model maker. Chance also played a role in giving him the idea for his legendary pendulum. He was inspired by a thin steel rod mounted on a fast-turning lathe. When Foucault gave the rod a playful twang, he realized that the plane of vibration did not rotate along with the rod itself. This gave him a brilliant idea. He assumed that the vibrating rod in the rotating lathe behaved just like a swinging pendulum on the rotating Earth. In the basement of his house, he first of all experimented using 2-meter pendulums with a brass weight. On his first attempt, though, on the 3rd of January 1851, the pendulum wire broke before any discernible movement had occurred. But he didn't give up, and 5 days later he was successful. The plane of the pendulum swing seemed to rotate. Foucault informed the Academy of Sciences of his discovery and demonstrated his experiment to the assembled scientists. He was able to show the Earth moving in front of their eyes. With the support of the then President of France, Louis Bonaparte, shortly to become Emperor Napoleon III, he attached an even longer pendulum in the dome of the Pantheon in Paris for a spectacular public demonstration. This time, he used a 67-meter wire and a 28-kilogram weight. To prevent any disruptive mechanical influence disturbing the experiment right at the beginning, the weight was raised and fastened with a string. This string was slowly burned through with a candle. The pendulum could now swing backwards and forwards in a regular rhythm. According to Newton's law of inertia, a moving body will not alter its direction of motion unless some external force is exerted on it. Once set in motion, therefore, a pendulum will always swing in the same plane. But because the Earth continues its rotation beneath the pendulum, so to speak, an observer will see an apparent change in the pendulum's direction of swing relative to the Earth and the building. In order to make the slow change visible, Foucault spread damp sand on the floor. The tip of the pendulum traces out its current path in the sand on each swing. The sand, of course, is moving with the Earth. To the observer, the rotation is slow but steady. Just as Foucault had predicted, the plane of swing deviates from its original course by about 11 degrees every hour. The deviation per hour or day is dependent on the latitude. At the North or South Pole, it would be precisely 360 degrees per day, because the pendulum would be immediately above the Earth's axis. The further it is away from the pole, the less the rotation. In Paris, it's 264 degrees per day. At the equator, there would be no apparent movement. Following the success of his experiment, Foucault sought a proof of the Earth's rotation that was independent of latitude. A year later, he presented a device which he called a gyroscope, a spinning top whose axis could turn freely in all directions. This meant that it could preserve its orientation in space in all circumstances, whatever the mounting did. The gradual movement of the axis vis-à-vis the Earth can be observed with a microscope. The specific properties of a gyroscope can be usefully applied elsewhere too. For example, the International Space Station, or ISS, uses 4 gyroscopes for stabilization purposes. In 1854, Foucault was appointed physicist at the Paris Observatory. During this period, he devoted much of his time to the further development of telescopes. Foucault built reflecting telescopes with diameters of up to 80 centimeters. He also refined the clockwork mechanisms which kept the large telescopes moving. And he solved another problem, one that had cropped up when observations were being made of the sun. To prevent the optics from overheating, he coated the objective with silver. In 1856, he developed a way of testing the surface quality of lenses and mirrors. The process, which is named after him, shows up polishing errors very clearly. Alongside many other awards, in 1855 he received the Copley Medal from the Royal Society of London, the highest distinction which that prestigious institution can bestow. But in his own country, honours were slower to come. It was not until 1865, on his 6th attempt, that Foucault was elected to the French Academy of Sciences. But soon after, his health began to fail. In July 1867, the first signs of paralysis appeared. He also found it increasingly difficult to see and to speak. 7 months later, on the 11th of February 1868, he died in Paris. Although Léon Foucault had never obtained a university degree, he became one of the most important scientists of his day. His work consisted of a fascinating mixture of pleasure in experimentation, applied science, and absolute precision. For some of his contemporaries, he was France's leading physicist. For others, no more than a gifted model maker. But Foucault's pendulum experiment has become legendary, and it is still being constantly repeated. There are more than 100 Foucault pendulums swinging in different parts of the world. One of them is in the UN headquarters in New York. They all help to keep alive the memory of one of the 19th century's greatest experimental scientists.